right. Howdy, y'all. My name's Mars. I work in Salesforce Platform. I'm a strategic engineer, essentially figuring out how to do new, very interesting things that a lot of people crave. So today I'm going to be talking about how we can use Terraform to automate your infrastructure and deployments with Heroku. So I'll kick this off by saying, please only make your purchase decisions based on generally available features. This is all open source. This is all basically experimental. You can definitely use it, but you need to understand it to apply it well. So hopefully this will kick you off in the right direction. All right, so today I'm just going to go through a few different things, going to give you a little background about what Terraform is. I'm curious how many of you already know what Heroku is? Okay, good, because this kind of steps beyond that level. This is all about how to use Heroku in even better, more forward-thinking way. And then we'll talk about essentially how to use Terraform in a collaborative way. Then I'll give you an actual demo. Most of this will be me showing how to do these microservices deployments with Terraform. And then back when I thought this was going to be a 40-minute presentation, I had a whole nother thing, a section about cross-cloud deployments with AWS and Heroku. I'm not going to go over that, but afterward, if you want to approach me, I'll also probably hang out over at the Heroku booth afterward, and we can talk about this stuff. So let's get started. So what does Terraform really do? Well, the principle of Terraform is that you can declare the configuration of all of the infrastructure in your data center in one configuration. So you can manage all of your different pieces of configuration, interdependencies, all within one consistent blueprint. And so when we talk about doing infrastructure as code, one of the key takeaways to me is like, can you rebuild production from scratch? And of course, with a lot of startups, this is a panacea because startups start small, scrappy. Before you know it, you have a production system that's making a lot of money, but you can't put it together again because it's been cobbled together for so long. So Terraform is a great way to embody how you put your technology together in a way that can be audited with code. So the ideals here, I'm not going to go deep into all of this, but the ideals are really that we want to level up our infrastructure to the same point that we use with our code for our applications, right? The biggest challenges, though, which I really want to call out, so manual config drift. I'll come back to this, but this is essentially where you provision things with Terraform, and then you go into like your Heroku dashboard or your AWS console, and you change those things. And then Terraform won't understand how to work with them anymore because you changed them behind it. This is something that happens with any infrastructure as code tool. If you programmatically build things and then you manually change them away from those programmatic tools, you're going to have a bad time. So it's just something to be aware of. It's something we're all trying to figure out better how to actually make these flows work better. And finally, destructive accidents. So the easier it is to provision your whole system, the easier it is to tear it all back down. And this especially applies to things like with Heroku Postgres, where it's like if you destroy a database, you've destructively destroyed the database. So you want to be really careful that anytime you use Terraform, you're very conscious of exactly how much impact it can have. So Terraform itself is a tool. It's built in open source on GitHub. So part of why it is becoming more and more popular is because they have an open source ecosystem of providers, essentially these plugins that let you build in Go an adapter that lets you then use Terraform to declare configuration for a service. So Heroku is just one of these. AWS is one of these. There's all different kinds of services. If we actually take a look at, this is the Terraform providers list. As you can see, there's a lot of things listed here. And then these are just the official providers. You can also just make a provider and like share it on GitHub. And so there's a lot of this out there. It's really powerful. Also, Terraform, when you build this code to express your infrastructure, it is a declarative language called HCL, HashiCorp Config Language. It's really designed for humans. And so this is what I'm going to be demoing here in a minute, but this is what HCL looks like. This is syntax highlighting in the Sublime text editor. But it's really clear, like here's a Heroku app, and you can declare some attributes for it, and you can attach add-ons and releases. This is a really great configuration language. It makes it really simple to be able to browse through and understand what's happening. All right, and then as far as what I mentioned about the destructive potential of being able to undo what you have done, HashiCorp Terraform does provide a workflow to help you avoid this. It's called the plan apply workflow. And the whole premise of it is that anytime you want to make a change with Terraform, you essentially run plan, or even if you just run apply, it's still going to show you line by line each resource, each thing it's going to change, create, change, or destroy. So you can really make sure that you're doing the right thing. Like you can audit along the way. All right, so I'm just going to jump right into now what it looks like to actually use Terraform with Heroku. So in this diagram, this is the, like, let's just get started, kind of the naive, like, let's just get started with Terraform. It's really easy to download it, install it on your own computer. And so what you see in this diagram is that we have a local computer where we run the Terraform commands. We store our configuration source code in GitHub. And from our local computer, when we run these commands, Terraform actually talks directly to the provider APIs. In our case, we're talking about Heroku. So when you run Terraform apply, your computer is talking to Heroku, doing all the configuration, provisioning these things. But the challenge here is if you want to collaborate on this with a team, the state is on your local computer, right? So you need to share that somehow. So Terraform provides a number of different backends, including an enterprise product that actually makes all of this like really beautiful. But I'm talking about right now just using the open source version. So essentially you can add to your local Terraform configuration a backend provider that, in this case, will actually store the state in Amazon S3 and synchronize it with the DynamoDB table. And what this then allows is that everyone on your team can check out from the same Git repository that source code. You can all do plan applies on your individual computers, but they won't conflict with each other. By storing that state in a remote, unified place, it's able to all work together without conflicting with each other. So with that premise, I want to talk about actually deploying microservices. So when we talk about microservices, this is kind of the smallest case, right? 2 applications on Heroku. Each of these horizontal gray sections represent a Heroku pipeline. Are you folks familiar with Heroku pipelines yet? Heroku Flow? OK, so pipeline, this is actually becoming a more standard kind of construct across other providers as well. But it essentially lets you set up your testing, staging environments all the way to production so that you can have a really great collaborative experience with your team to be able to test new features, promote them through, to have QA look at them, and then out to production. So when we talk about microservices, these 2 services, in this case, this web UI and API, they need to know about each other in order to work together. And so we have some challenges here. So the challenges are, as I said, that interdependent app configuration. Like when you set up one of these apps, how do you make the other app know about it? Also, being able to just fully reproduce this over and over again. Like, how do you know that your production system is reproducible? So also sharing add-ons. So another Heroku feature, this is where You attach databases, logging systems. So logging is a great example of this. Like, what if I want my web UI and my API to both share the same logging attachment so that I can see the logs together? Well, you can definitely do that with Heroku. But the challenge is, how do you automate setting that up over and over again? And then finally, integrating with external services is another challenge here. So what I want to share with you today is how we can essentially create a terraformed production system. And then we can use the Heroku pipelines to essentially be our build system, to generate what we call slugs at Heroku. So slugs are like the container of code of your app. And so with this, we'll be able to essentially maintain our Heroku developer experience, right? We're able to still use pipelines fully. But when we talk about where we serve production traffic, it's actually from an environment that is completely controlled by Terraform. And the way we promote our code from our build system to our Terraform system is through this little release process I'm about to demonstrate. All right, so let's jump over. Yes, so this is the code I'm working with. I will show you a screen of all of the links to all of these different things that I'm working with here today. So this is actually the Terraform repo. This is open source and available for y'all to check out if you want to understand more about the code behind it. So this Terraform config is, I have already provisioned it. So let me jump over here again. So to provision it, we run Terraform apply. So if I run Terraform apply for this particular project, what it's going to do, oh, we can't even see my command prompt, can we? OK. I'm a little confused about what's happening here. All right, so as you can see, what's happening with the video? So what Terraform is telling us here is it's going to explain all of the individual resources it's going to provision for us. So here it starts by talking about the add-ons it's going to provision. We get through to some apps. And essentially here at the bottom, it's going to say, OK, we're going to, because this is the first time, we're going to create 18. We're going to add 18 resources, and nothing's going to be changed or destroyed. Now, this can take a few minutes, so I'm not actually going to run that right now. But here is the same config, and it has been provisioned now. So at this point where we would have entered yes in that other one, here you can see it actually going through this process of creating the app, creating config vars, all of these different resources until it gets to the point where we have added 18 resources through Terraform. So Terraform lets you declare outputs. So in this case, there's a couple outputs here. These are the DNS records that represent where I should point my production domains. And so what this actually creates is this cute little website. It's a little robot talking about, creating haiku based on my current IP address. So if I refresh it, that is the haiku for my current IP address. Here you can see I have a staging version of this as well. And so what I'd like to show you now is how we can actually create a pull request on GitHub to make a little change in that little robot UI, and then see how we propagate that change through to our terraformed resources. So I'm going to go to the web front end for Tiny Robot. I'm going to go into my component here. I'm just going to make a quick edit. And we're going to turn our robot from blue to dark orange. And I'm going to create a new branch with a pull request. And create that pull request. And then we'll take a look at the pipeline. So this is our Heroku dashboard for my entire team that encompasses this whole demo. And here you can see we have this web UI build PR6. So this is my review app coming to life. I'll actually go to the pipeline here where you can see this review app being built. So this is the pipelines interface. If you're not familiar, there's a lot of amazing features in here. We have a CI testing system. We have this system called review apps. So we're using review apps right now. Review apps are an amazing feature. They let you essentially automatically provision a new version of your app for every pull request that's opened on GitHub. So it makes it really simple to be able to evaluate, try out your different developers' features. All right, so we now see that that has been released. And if I go visit that app in a web browser, you'll see we now have an orange robot. It doesn't know what my IP address is right now because this is just a front-end review app. So I'm going to go to GitHub and go ahead and merge that because that's what we want to actually promote into our system. So that has been merged. If we go back to our pipeline, we'll see that the review app has already been torn down because the pull request is closed. And here now it's going to build the same app in our staging environment. So the staging environment, one of the things that I want to make really clear about this is that when we think about the architecture that's working right now, what is building is that middle staging build, right? And so we can internally go look at these Heroku apps, like using their URLs. But we have this whole second terraformed environment, right? And so once this app is built, which I think it is, yes. OK, so now I'm going to come back to Terraform here in my command line. And in order to do this, so let's see here. Here it is. So I just want to call out, once again, that this step right here, where we pull the app slugs out of the pipeline and essentially deploy them with Terraform, we have a little adapter script that queries the Heroku API in order to get the slug IDs. And so that is something that I'm going to run right here. So this source bin pipeline slug IDs right behind my head. So this is, it's actively going, asking the Heroku API for the slug IDs. And now, if I run a Terraform apply, Terraform's going to go check with the Heroku API what is the current state of all the resources. And as you can see, it's telling me, OK, we've got a new slug. We're ready to release, right? So right now, I'm just releasing one slug. But a huge part of this story is that because this is a microservices deployment, we might have multiple apps that we want to promote all at the same time. So we could easily do that. And in fact, if I was to cancel that and come back here, actually, I don't have time to do that. Let me just go ahead and promote it. So we'll just run this again. We say yes. So now it's going to release that new slug into our terraformed infrastructure. The video went black again. OK. So now, if I step over to my web browser, so this is my staging environment. And if I refresh, you'll see our robot is now orange. So we have successfully promoted through Terraform to make our Heroku apps actually, updatable together. So there's a few other really great points about this, like the shared add-on story. I'd love for you all to come ask me more questions afterward. There's just not enough time right now. But let me get to the thank you. And here's the links to what I've been demoing. So I hope I've piqued your interest in using this technology with Heroku, enable holistic deployments and auditing of your infrastructure through code. Have a beautiful Dreamforce. Thank you very much.